Hello students, welcome to this really nice topic which is similarity. Similarity is one of the most magical things I have learned and taught, and therefore I shall call this series of videos as the magic of similarity. There are several magical results that you can quickly obtain in elementary geometry with the help of similarity, and in fact I would like to go ahead and say that you'll probably use similarity for several amazing results throughout your lives. So let us quickly define what is similarity. So you can take up any shape, but I am going to take up a triangle. If you enlarge the triangle or diminish the triangle, we say that all the triangles here are similar to each other. So the most important thing to remember in two similar triangles is the fact that if triangle ABC is similar to DEF, then the corresponding angles are same. So I'm just marking the corresponding angles, and this is the standard way of showing that they're equal. So the corresponding angles are equal and the corresponding sides. So suppose you say that ABC is similar to DEF, and if you've already got the order right, that is angle A corresponds to angle D, angle B corresponds to angle E, angle C corresponds to angle F, and you've got the order right, then the consequence is very easy to write. We say that the side AB divided the side DE is equal to the side BC by EF, that is BC corresponds to EF, and that is equal to AC corresponding to DF. So the sides, so I'll just mark it here on the diagram, AB and corresponding to DE, and BC corresponds to EF, and AC corresponds to DF, and the ratios of these corresponding sides is equal, and let's simply call this ratio as K. Now K can be greater than 1, in which case it's an enlarged figure, or K is less than 1, in which case it's a diminished figure. And of course K equal to 1 means the two triangles are congruent, but at this juncture we are more interested in similarity rather than congruence. So what is the criteria to decide that two triangles are similar? And the answer is that there are three criteria. AA, so if two angles are equal, then the two triangles are congruent, similar. And then you have SAS, where two sides are proportional and the included angle is equal, or SSS, the three sides are proportional to each other. Now these are the three criteria to decide that two triangles are similar. Now why is it so? Well, we can easily prove this, and the proofs are really illuminating, and one should actually go through these proofs sometime. Maybe we can do it in one of the future classes, but at this moment I really want you to know that the basic proportionality theorem that you learn in class 10 or maybe class 9 is all you need to prove the three criteria of similarity. So with this background in similarity, let's unfold the magic of similarity by a series of nice results. So in this particular lesson, I shall talk of one which is my all-time favorite. So let me slow down on this. We shall take a right angle triangle, and we'll make sure that the triangle right angle is on top. So this will be 90, and now let me label this triangle with the standard convention. So if I call this as A, B and C, then this side AB will be called small c, and this side will be called B, and this side will be called small a as per the convention. So what is C? Is the length AB. So let me just show it like this, and A and B is pretty clear. Now at this stage I shall drop a perpendicular from C and this is going to be 90. Now, there are two new triangles that have appeared, which I shall call as daughter 1 and daughter 2 of the mother triangle ABC. So, the mother is similar to the daughter, which is also similar to the other daughter, and this is pretty easy to see that the three triangles that we have mentioned here are similar to each other, and the reason is pretty simple. If we call this acute angle as alpha, then it is pretty clear that this angle will also be alpha. That is because this angle is 90 minus alpha and these two angles are 90, and that would mean that this angle is also 90 minus alpha. Now, because of the angles shown, you can see that all the three triangles have their angles as 90, alpha and 90 minus alpha, and therefore it is very easy to see that all the three triangles are similar. Now, let us make use of, let us look for the consequence of the mother being similar to the first daughter, and I shall write it down very carefully. So, this is the mother triangle ABC, and it is similar to the daughter number 1. So, let me look at the daughter triangle, but let's call this point as D, and let's call this side as small d, and this side as small e. Okay. Now, the angles C in the mother is 90 and the corresponding angle in the daughter is D. Now, angle B in the mother is alpha and it is also equal to angle B in the daughter, and that leaves C. So, angle C in the daughter is 90 minus alpha, and you can see that angle A in the mother is also 90 minus alpha. So, with that I have got my order right. There is absolutely no problem with the order, and now this will make it easy for me to write down the consequence. And the consequence is that side AB divided by side CB is equal to side BC upon BD, which is equal to AC over CD. Now, please fill in these information by looking at the diagram. Please do look at the diagram. You can see that side AB in the diagram is nothing but C upon CB, which is A, that is equal to BC, which is again A, and BD, which is D, and that is also equal to AC over CD, but actually I don't require it for my first magical result. In case you want to write it down, you could, but for that you have to label CD as the H, and like I said, let me just focus on this result. Now, this is a wonderful result. This implies that A square is equal to CD. Okay, now this is so important that I'm going to box it in a double fashion. This is really the result I'm gunning for. A square is equal to CD. Do look into the figure. This is your A squared is equal to C multiplied by D. Now, let us see what happens if this mother is similar to the second daughter, and I'm not going to repeat all these steps, but they are very similar and you are invited to write it down, you are encouraged to write it down, but perhaps you will agree that by symmetry, what you can expect, the similar result that you can expect is this B square will be equal to, I'm going to show this now, this is easy to guess by symmetry, that it will be equal to CE. Okay, so B square is equal to CE. Now, this is the wonderful result I am looking for. So let me box this. Now let me erase some of the things that I don't require to pull in my last magical step. Okay, so we're ready now for the magic. We just have to make use of these two results to get a really wonderful result. Now, whenever I've done this in class 8 or class 9, it almost brings out a wonderful gleam in the eye of every student. So let me see, it should happen again if you're looking at it for the first time. So I combine both these results in the following way. I shall write this as a square plus b square is equal to CE plus CD. Now this is equal to C, I'll take C common, and it will be E plus D. Okay, at this juncture, I please ask you to look into the figure here, this figure here, please. And now you will see from the figure, it is very clear that C is actually equal to D plus E. Now this is very obvious in the figure that C is equal to D plus E, and this is exactly what I need to substitute in the last step here. And so this will be equal to C into C, which is equal to C square. And with that, we have proved perhaps the most beautiful result in elementary geometry, which is a square plus b square. Let me just make some space here. A square plus b square is equal to c square, the great Pythagoras theorem, which has got God knows how many hundreds of proofs, and here is my most favorite proof of the Pythagoras theorem. Now this is clearly come from similarity. So this is the magic, this is the first magic trick of similarity that I have presented, and I shall proceed to have at least 2 to 3 more video lessons on this topic of the magic of similarity. And as far as this lesson is concerned, we are done. Please do write down the missing steps if you are doing this for the first time. Thank you and see you soon.